Hello, my name's Keith Rucker. Project for this video is we're getting ready to install the curved surface pulleys that we have a whole series of videos on now. Everything from making the wooden patterns to having these cast and then machining these out. I had to send them over to Keith Finner to use as tracing attachment on his lathe to cut the contour profile on them, which is up on his website. But we've got these back now, and they are ready to go onto the Vance Matcher. These are the shafts that these pulleys will go to, and these shafts will drive the side heads on this planer matcher. So up on the top of this, these shafts will be going up and down, and up here is just basically a cutter head that you put wooden knives on for cutting wood, like a tongue and groove type knife, like tongue and groove knives. So anyway, the shafts are already made. We've already got the babbitt poured for these. These are ready to go. The only thing left to do is to get these pulleys mounted on these. So and they will go in here just like so. So in order to do that, we've already got again the pulleys completely machined, and one of the steps that we did while doing these was we broached a keyhole or keyway into the top or into the bore of the pulley. And now the job is we need to put a keyway in these shafts. I purposely waited until we got the pulleys done so I would know exactly where to put the keyway on these shafts. So to cut this keyway, there's several ways you can do that. Of course, the most common way is just to use an end mill and a vertical mill. However, I personally just like cutting keyways on my horizontal mill using a wheel type cutter like this. And so that's what we're going to do today, is we're going to set up our horizontal mill. We'll use this cutter to just come down through here, cut the keyway, and then everything will be ready to go back on the machine. So let's go over to the horizontal mill and get it set up for cutting out a keyway. So this is my horizontal milling machine. This is a Kearney and Trecker Model H milling machine, fairly common machine, I guess, as far as horizontal mills. They made a ton of them in this size. This is a very useful size. It's not too big that it takes up a huge amount of footprint, but it's got a big enough table and work area on it that you can do an awful lot of work on these machines. Now, I've talked about before horizontal mills versus vertical mills. Vertical mill has really become the standard, I guess, in machine shops now. Really, very few shops even still have horizontal mills. Whereas one time the horizontal mill was the standard, and really the vertical mill was not nearly as common back many years ago. But with the advent, particularly with CNC machinery, the vertical mill has really kind of replaced the horizontal mill in a lot of applications. However, I will say that a horizontal mill is a very useful machine, and in a lot of ways is really more versatile than a vertical milling machine. Particularly if you have a vertical head on it. And probably the biggest advantage to a vertical mill over a horizontal mill is the quill, where you can do drilling operations. And if you think about it, a lot of people really use a vertical mill more as a drilling machine than they do as a milling machine. Again, I have both. I wouldn't trade my vertical mill. I love it. I use it a lot. I probably use it more than this machine just because it is convenient, which is why they've become probably more popular. But for applications such as turning a cutter like this, and for a lot of really heavy milling operations, you can do an awful lot or on a horizontal mill machine. So point being, don't discount the usefulness of these machines. Just because every machine shop doesn't use one anymore doesn't mean that they're still not useful. So we're going to go ahead and get this set up, and I'm not going to spend a whole lot of time talking about the details of this. I actually shot a video a while back on cutting a keyway on the horizontal mill where I went into a little more detail. So we're not going to rehash all that. If you're interested in that, you can go back and find that video in my library and take a look at it. But to get started, we're just going to use this arbor here. This is an 1.25 inch arbor. We'll put it into the mill and tighten it up on the back. This is just a 50 taper socket. Really the same type of thing that's used in a lot of the actual CNC mills now. This 50 taper goes back many years, and that was what was used on this machine. So I have a 50 taper in here. If I'm using my my vertical head over here, it actually has a 40 taper in it, but 50 taper coming off of the machine itself. So let's get that tightened up, and we'll be ready to set this one up here. Okay, the arbor is now ready, so we're going to be doing our milling somewhere about in the middle of this shaft is where we want to mount the cutter. So I'm going to strap it down to the table, and let's see, we can cut it about right in there. So these are just some spacers that you can put on your shaft to kind of take up space and get your cutter where you want it. These come in all different thicknesses so you can get something right where you want to. That's going to be about where we'll put that. We'll put the actual cutter on here. It's keyed onto the shaft, so I have a keyway here. That's going to hold that in there. The cutter will be turning in this direction, and now we're just going to go ahead and put on some more spacers until we get out. I don't want to go on there. There it goes. Alright, so now we're past the keyway. The next thing I'm going to do is put this piece on. This is a bearing for my outboard holder here that will give some support, outboard support on this. You'll see that in a moment, so I'm going to go ahead and put that on next. That's where the that will go, and then I'll put some more spacers on here to take up the rest of the space until we can get our nut on. So that'll get our nut, and then this screws right on. And all this is just sandwiched in place, and I'll tighten that up and we'll be ready to put the overarm support on. So now I'm going to crank out the overarms. There's just a rack and pinion on those on the machine where I can pull these out, and I'm going to pull them all the way out right now, or pretty close to all the way out. Alright, that's pretty much fully extended, and let me wipe these down, put some fresh oil on them too. This is just whey oil. So this is the overarm support, and I'm just going to make sure I wipe these down real good. Make sure there's not any trash or anything in there that will prevent these from sliding right up on these overarm. And beautiful. Alright, we will tighten that down right there. Put some oil in here where that bearing's going to go. It's just a bronze bushing in here that bearing is going to spin inside of here. So now I'm going to again use my rack and pinion to pull this back in. That should start right on that bearing right there, and it does. Perfect. And I'm going to stop right there because that bearing is now in that bushing. So this is going to give us the support over on the overarm here to just make this shaft in here just as rigid as possible. And now I'm just going to tighten up these nuts on the top. Will tighten the overarm so that they won't move. Go. All right, so the cutter head is pretty well set up on the machine now, and we're just about ready to go. This fill hole here is just a reservoir that holds oil that will then drip down on this bearing as we're using it. So I'll just pump some oil in here. That should be enough. Again, there's just a reservoir built into this and a small hole that goes down into that bronze bushing that will keep that lubricated while we're running the machine. Alright, I'm getting this strapped down to the table here. I'm just strapping it right into one of the slots in the mill table. This is a good way to always put down shafting, because that's going to give you a good parallel surface that you can mount in. It's just going to center up on that, and then we'll clamp it on the top here just using a regular toe clamp. And I'm taking a little piece of brass and putting up on it because these are bearing surfaces that I've already poured my Babbitt bearings for, and I don't want to scar those up at all. So, and we're just going to snug these in place. Alright, so that should be our everything strapped down to the table now. Machine is powered on. Need to raise the table up. Use the auto feed, bring that right on up. At least get it close. Let's run this out to the beginning of the cut, which will be somewhere right along in there. Alright, I like that. That's about 45 RPMs. With all those cutters on there, that's a lot of cutting power there. So, alright, now we're going to get this centered up on the shaft. So I'm just going to raise it up. Let me eyeball down it and kind of roughly get it centered. There we go. I'm just going to raise this up until it kisses off. Alright, there we go. And I'm just going to move my cutter back and forth across that. And I think I went too deep to start with. I did. No big deal. Let me just come in here. What I'm doing right here is I'm just raising the table up until I can get a mark on there that is the same width as my cutter, and then I can use that to center everything up. So I just raise it up a few more thousandths. I'll skim across. That's right on the very edge of the mark. This is pretty good right here. Get my flashlight. That's right on the edge over here. That's on the edge there. I like that. That's center of the shaft right there. Alright, we need to get this cutter down to depth, so I put my indicator in here. The width of the cutter is 3/8 of an inch, which is 0.375. So we need to go half of that depth, which will be 3/16, which is 0.1875. And I always like to have just a few extra thousandths in that depth. So we're just going to go to 0.190, which will give me about a 2.5 extra thousandths in there. So I've got my dial indicator set up over here. We'll go ahead and start the machine cutting, and we're just going to raise that cutter head up a little bit at a time until we get to 190 thousandths. That'll be 100 thousandths. $190 thousandths. Put some oil on this cutter. And now we will just start our feed. I have my feed set on 5/8 of an inch per minute right now. Alright, I just increased my feed to 3/4 of an inch per minute. And that looks like it's cutting very well. And I think it can take a little more feed, so I'm going to move it up to 1 inch per minute. I have a mark on my shaft right here where I want to stop at. Alright, that's about the end of my cut, so I turn my feed off, and this one's pretty much done. Alright, let's see how all this goes together now. I got the Keyway cut, I got a key cut, and we'll just slide this in here. Alright, that's going right up in there. I just wanted to hit a snag right there. I know what this is. When Keith Fenner did this, he put a little piece of brass in the bottom of that Keyway because he was tightening it down onto a shaft. So I'm going to pull that out. That was actually getting caught on the Keyway as it was coming in, and it was catching right there on the back and keeping it from going that last little bit. So it should go right in now, and let's see. There we go. That's perfect. And for this, I would rather the set screw just go straight on top of the Keyway anyway. So that one is ready to go on the machine. Let's get the other Keyway cut, and we will go put these on the machine. Alright, pulleys are installed and on the machine now. We're ready to put the side heads back on now. I thought I'd go ahead and show you guys how these cutter heads go on here, because when I put all this together, it was back before I was shooting videos, and I know a lot of people have been asking about what this machine does and how it works. So we have the two spindles coming up from the bottom where those pulleys are. And what is on those is this square head cutter head, and it has T-slots in it that you can basically bolt knives to this, and you can either put a flat knife if you're doing a straight edge, or a contour, or a molding knife, however you want to. So anyway, these are on here, and the way I've got these done is there's a plate in the top of this head that's pressed into the hole. It has a tapped hole going through it and a screw. So this is the fine adjustment on this. I can just use that and move that up and down. So say you've got a tongue and groove molding knife in there, and you need to adjust the head up and down. That is how you would do just a fine adjustment right there to get it just where you want to. Now on the shaft, you can't see it, it's on this side, there's a flat that's milled into that into the shaft, and then I have a set screw that comes in here. So what I have to do is just kind of rock it and find that flat. Okay, see, the flat's in between those 2 points, and tighten it down, and then that's going to keep that cutter head from spinning on the shaft. And then I can set the jam nut there to get the depth right. So that is basically how we put the heads on. And go ahead and do the other one while I'm right here. Get my set screw in there. Again, just tighten it down. Evidently I had it about out. Alright, there you go again. There's the flat right there. That one is tightened down, and the heads are installed again. And this cutter head is going to turn this way, so it's cutting, feeding into the board as it's going around. This one here will come around the other way and feed into them, so they both turn in opposite directions of each other. So that's pretty much it. We have the pulleys mounted on the machine now. That step is done. The side heads are pretty much all done. So check one more task off the list on the Matcher project.